Hello everyone, welcome back to my channel once again. So yesterday we started discussing about the sequential circuits, and as a part of the discussion we started to discuss about latches and flip-flops. So we were done with SR latch. Now today let us see what an S bar R bar latch is and how it actually works like. So as you all can see, this is a logic symbol of an S bar R bar latch. So here S bar and R bar are the two inputs and the outputs are Q and Q bar, and this is an S bar R bar latch. Now coming to the logic diagram. So how will the logic diagram actually look like? It is similar to that of an SR latch, but the main difference you observe is here the gates which we used in SR latch were NOR gates. But coming to S bar R bar latch, the main change is we are going to use NAND gates. So these are two NAND gates. Let me number them as 1, 2, and here also it is the same construction using cross coupling. So the first input to the first NAND gate is S bar. Similarly, one of the input of the second NAND gate is R bar. Then what about the remaining inputs of the two NAND gates? So for the first NAND gate, the input is given through the output of the second NAND gate, and the input to the second NAND gate is given by the output of the first NAND gate. So this is how a logic diagram actually looks like. Now coming to the truth table, my first combination will be 1, 0. So for 1, 0 combination, that is my S bar is 1 and R bar is 0. Again, to know the mechanism of this S bar R bar latch, you have to know the truth table of a NAND gate. So what is the truth table of a NAND gate? 0, 0, 0, 1, 1, 0 and 1, 1. For a NAND gate, these are 1s and this is 0. So this is the truth table of a NAND gate. So here, one of my input is 1 and the other input, for the second NAND gate, one of the input is 0. So irrespective of my second input, irrespective of my second input, if one of my input is 0, as you can see in these three cases, if one of my input is 0, irrespective of the second input, the output will be 1. Therefore, my Q bar is now 1. And this Q bar goes as second input of the first NAND gate. And 1, 1 of my NAND gives me 0. Therefore, for this combination of 1, 0, my Q is 0 and Q bar is 1. Now my next input is 1, 1. So S bar is 1 and R bar is 1. So here, as already discussed in S bar R bar latch, here for 1, 1 there in SR latch, for 0, 0 combination we have took the previous state of Q. But here in S bar R bar latch, for 1, 1 combination we have to consider the previous state of Q. Therefore the previous state of Q here is 0. So my Q is directly 0 and this 0 goes here. Now 0, 1 combination of my NAND gives me 1. Therefore my Q bar is 1. Now my next combination is 0, 1. So S bar is 0 and R bar is 1. Now irrespective of the second input, if one of my input is 0, the output will be 1. Therefore my Q is 1 and this 1 comes here. My 1, 1 combination gives me 0. Therefore Q is 1 and Q bar is 0. Here you are not considering the previous state of Q because this is totally a new combination. This is not a reset combination, but it is a new combination. Now again we have to consider the combination of 1, 1. So again, while considering the combination of 1, 1, you have to consider the previous state of Q, that is 1. So 1, 1. So 1, 1, that is S bar is 1, R bar is 1 and Q is also 1. 1, 1 gives me 0 and this, so my Q bar will be 0 because 1, 1 gives me 0. Now the last combination will be 0, 0 combination. So for 0, 0 combination, so for my 0, 0 combination, my S bar is 0, similarly R bar is 0. So irrespective of the other input, if one of the input is 0, my output will be 1. So here it is 1. Similarly, here also it is 1. If you take this as 0, then output will be 1. Or if you take it in the second method, that is getting Q over here, my 1, 0 combination also gives me 1. So here, as you see, my outputs are 1 and 1. But Q and Q bar need to be complements to each other. But here this fact is contradicting. That is, if Q is 1, my Q bar should be 0. If Q is 0, my Q bar should be 1. But here, both are 1s. So this is an undefined state. Now coming to the function table or the characteristic table, let me fill the inputs in an order 0, 0, 0, 1, 1, 0 and 1, 1. Now for 0, 0 I got it as 1, 1, and as I already said, this is an undefined state. Now next, for 0, 1. For 0, 1, my outputs are 1 and 0. So irrespective of my inputs, my Q is 1. So this is a set state, because as I already said in the previous video, set is represented by 1 and reset is represented by 0. Now next, for my 1, 0 combination, my outputs are 0, 1. So irrespective of my input, my output is 0. Therefore, this is a reset state. Now for 1, 1 combination, I got it as for 1, 1 combination, here it is 0, 1 and here it is 1, 0. That is, it is resembling the previous states. Here it is 1 and here it is 0. It is resembling the previous states. So it is a no change condition and the state is the previous state. So this is how an S bar R bar latch works. In my next video, let us discuss how a gated SR latch works like. Please do not forget to like, comment and share. Please do subscribe my channel and extend your support. Thank you. Have a good day.